Alright, iron cores of ancient stars. Now, when you have stars, such as the Earth, what you have is an iron core, you have an outer iron core, and you have a mantle, and then you have the crust, thin crust. Now, the thickness of this object right here is massive on the Earth. I think the radius is 1,220 kilometers, so that would be 2,440 kilometers in diameter. That is a massive iron nickel ball, okay? That is a large structure, okay? Incredibly huge, sitting in the very bottom core of the Earth. Now I know all those hollow Earth people are like, oh, the Earth is hollow, there's a sun interior. No, it's just a giant crystalline ball of iron and nickel. Now, in stellar evolution, you have the star in the very beginning. Now, this is going to be a bit, should I say, creative. I don't know exactly how a star is born, but I'm just going to go over what I think happens. You have a giant molecular cloud, okay? Now, there's a lot of electrical buildup in this cloud. And eventually, some of that buildup does want to equalize in areas, so it starts to pinch in the center. And it creates a magnetic field. And this magnetic field further confines itself and continues to pinch in the center of the star, heating that material up. So the force is directed this direction, this direction, this direction, all towards the center of that object. And eventually, once that central object is formed, actually that object would look like a big, a Z-pinch, just like this, with a new object in the center. A Z-pinch forms a star. That's what I think happens. But after that Z-pinch is formed, what you'll have is a little tiny white dwarf, okay? Now, these things are really bright and really, really, really hot. So to dissipate the energy, what they do is expand. And bigger, bigger, bigger. Now go down here. Bigger, bigger. And then they dissipate the heat like this. So eventually, what you end up with is a giant hollow shell of plasma. And this is the very tippy top of the Hertzsprung-Russell diagram that I had drawn earlier. You know, with the top stars right here, going down, and then you have the planets, obviously older stars. But I think what happens is the star is born down here, and then it moves its way up as a white dwarf, expands, and then it starts cooling as it goes down that graph. So this big hollow structure right here would be something like a blue giant. That's up here on the Hertzsprung-Russell diagram, okay? We're going to start there. We're going to start where the blue giant is. So the blue giant, big, bright, hot. And what happens is this thing will gravitationally collapse on itself. It's not going to be a giant hollow ball forever. It's going to eventually shrink. And what happens when it shrinks? Well, the shell collapses. And it cools. Its luminosity changes. It doesn't radiate as hot as it used to. So you had 25,000 Kelvin. And now you have 15,000 Kelvin, and then it'll continue shrinking and gravitationally collapsing on itself until it cools further to maybe like 10,000 Kelvin, and then even further to about where the sun is, 58, 80 Kelvin. So you have this thin shell. Now I remind you, it was even thinner when it was a blue giant, so this thin, thickening shell, I should say, okay, is still hollow, and it's still cooling. And over time, that shell cools, further contracts, and eventually all that material starts condensing in the center. And it becomes not a plasmatic star, hot, very, very hot, to a cooler, gaseous star. Now this would be red dwarfs right here, and then you have the gaseous star right there, brown dwarf. Now the spectrum would be an invisible spectrum for those sun-like stars, but as they cool and die, what happens is the spectrum diminishes considerably and it just reddens, eventually to the point to where it only radiates infrared. Infrared. So that's the WISE telescope. They find these brown dwarfs in the infrared spectrum. But what a brown dwarf is just a really old star. That's all it is. It's not a failed star, it's an old star. So then, okay, I'm going to draw a little bit bigger here. This brown dwarf, which has all this material in it, okay, that material will continue differentiating itself based on the ionization potential of the elements. Now, the element that wants to move towards the center first is obviously iron and nickel. They want to move towards the center first. So what happens is inside that brown dwarf, the little ball starts forming in the center. And it starts contracting. And all this other higher energy material stays put. Okay? And that is the beginning of the iron core formation of ancient stars. This is the core of a brand new Earth-like star. And it begins during brown dwarf stages of stellar evolution. All right.